Hello students, I would like to give you an idea about how we are going about the syllabus. So there are 10 chapters in physics. You can see the 10 chapters here. We have done the physical world and measurements, that is the units and dimensions and everything. We have done kinematics, and we are there in laws of motion. That's the third chapter, followed by work, energy, power, and all these things. It comes till the end. And also I will just take you through the syllabus, laws of motion. So the laws of motion is divided into 4 parts. A part is the part of just the definition of force, and as well as the Newton's the 3 laws, and then your the ways we were able to define about momentum, law of conservation of momentum, and all the things. And then we went on to study about B part, that is force diagrams, the various diagrams we had, resolution of vectors, and various equilibrium, and the numericals related to that. The next one is we finish about friction. So after doing this, the last part is angular displacement, angular velocity, angular acceleration. This is something to do with the circular motion. This entire thing is called circular motion. So friction we finished, and we are there in circular motion now. So we will be studying in today's class the first part of circular motion. So how it works, what are the various definitions which is involved, and some of the derivations which will follow. That I will do in the next class. But when you look at the book, in page number 296, it is written chapter 8 as uniform circular motion, which is just followed by the previous chapter of friction. So don't get misguided by the chapter 8, but is actually in the whole thing it is called chapter 3 according to the syllabus. Okay, there are 4 parts. We are doing the 4th part of the laws of motion. So we are still very well inside laws of motion, right? And in that one, after friction, we get the uniform circular motion. Syllabus is written here. So it is the dynamics of uniform circular motion, centripetal force, and then the examples of circular motion. This is the basic things which is there. So let's go ahead. Let's start with the basics. Please make sure this particular things, whatever I am saying, it is very, very important, because in the syllabus you have another very important chapter called motion of a system of particle, chapter number 5, and rigid body. This is completely to do with any body which is rotating, rotational motion. So what we are doing in laws of motion, a last bit, circular motion, will be continued in this chapter. So that time we will not be declaring many things in detail of the basic definition. So you have to be very careful about the basics of this particular chapter. Some of them it will be quite new for you, or some of them it could have been studied earlier. It's okay. With this introduction, let's start. Circular motion. The motion of an object is said to be circular motion if it moves in a circular path. You know this one before itself. Any body moves in a circular path is called circular motion. The circular motion is an example of a motion in a plane. This is called motion in a plane itself. Okay. Examples are given here. Motion of Earth around the sun. So rotation of an automobile wheel, as well as electron moving around the nucleus of an atom, and motion of a particle which is tied on one end of a string and moving in a circle with the other end held in a hand. These are the various motions there. The circular motion can be considered into the 2 basic divisions, that is called uniform circular motion and non-uniform circular motion. This also you would have studied in the previous lower classes. In a uniform circular motion, when a particle moves on a circular path with a constant speed, then the motion is said to be uniform circular motion. So look at this one. There is a body which is moving in a circle. It was earlier in P, and then it goes in the same velocity, maybe 10 meter per second. It goes in the same velocity of 10 meter per second along the circle and goes to Q. It is also 10 meter per second. Here also it goes to 10 meter per second, and again it goes back to S. It is 10 meter per second and coming back to the same point where it started 10 meter per second. Now all over the points in the entire of the circle, it was in 10 meter per second. Now tell me, is it the velocity, if it is 10 meter per second all along the circle, then what is the acceleration? What do we know about it? When the velocity is same throughout the journey, then acceleration is 0. But remember, acceleration is not 0 in a uniform circular motion. Now the question mark comes, how? Same velocity is there, velocity v1 and velocity v2 upon t, change in velocity upon time. So this is also 10, this is also 10 divided by time, so acceleration is 0. That's what the acceleration definition is. Acceleration is simply change in velocity, rate of change of velocity divided by time. So how come it is acceleration is not 0? That thing, it is quite clearly given in this one. Speed remains constant but velocity changes continuously. What we talk about is only speed. The v is only the speed. It remains constant, but velocity changes continuously. How the velocity changes continuously is, look at the direction of the velocity from p, it is directed here as along the tangent. When it goes to q, it does not have the same direction as that of p, the direction changes to the tangent here. When it comes to r, the same body with the same velocity, it looks like the same velocity, but the direction is different. Here also direction is different. So since the direction is different, it says the velocity v1 and the velocity v2 is having same magnitude but different direction. v1 vector and v2 vector, remember, it is not going to just cancel out like this. v1 minus v2, you cannot cancel out like this because it is 10 meter per second and this 10 meter per second and it cancels out. No. Because the direction is different, you cannot deal the same way what you have been dealing with this. Okay. So it indicates the velocity vector at different points, different position of the particle is constantly changing. In each position, the velocity vector is perpendicular to the radius of this one. So here also velocity vector is perpendicular here. Here also it is perpendicular to the radius. It is perpendicular to the radius. Here also it is perpendicular to the radius. Okay. Due to the change in velocity, uniform circular motion has an acceleration. There is an acceleration whose magnitude remains constant. I said magnitude remains constant, but the direction changes continuously. However, at every point the acceleration is directed towards the center of the circular path. Now, when the body moves in a circular motion, the velocity is in this direction, v1, and this is the radius. Which direction the acceleration is? It is directed towards the center. Acceleration is directed towards the center. Here also, this is going in this direction, v2, but acceleration is directed towards the center. And he is going here like this, v3, acceleration is still directed towards the center. So everywhere, the acceleration is directed towards the center. Please remember that it is directed towards the radius of this one. So this is called uniform circular motion. Same velocity, speed is same, but velocity is in different direction. Please remember that. The next one is non-uniform circular motion. Now this is okay. Maybe you tie a small string and a big body is there and you rotate this. You are constantly spinning it. Have you done that one? Take a stone, tie it to the string, and you are just keep on increasing the speed. So the body moves very fast and comes back to this position. That is called non-uniform circular motion. When the particle moves on a circular path with a variable speed, then its motion is said to be non-uniform circular motion. So, okay, so some of the examples are given here. You can just read it. Now we will go to the important definition. The first definition, please write down: angular displacement. Angular displacement. And draw this diagram. Draw a circular path. Put an angle here. That is delta theta. And then put A and B point with the radius vector. So the angle swept, look at the definition, the angle swept out by the radius vector in a given duration is known as angular displacement. Now there is one word called radius vector. Now what is radius vector is, how can a radius be a vector quantity? Now there is a circular path and this is the radius. It has a vector quantity. It is shown as a vector quantity here. Now from this point the displacement takes place to this here, right? And it sweeps an angle of delta theta. From A to B it goes. Now what is that from here to here? This is called delta S. The distance displacement is this one, right? Now what is the definition it is? Angular displacement is defined as delta theta is equal to the arc, the length of the arc delta S to the radius of the circle. Delta theta is equal to delta S upon radius. So here also delta theta is equal to delta S upon radius. So you can write down the angle of the revolution, delta theta is known as the angular displacement. This is called angular displacement. What is this one? This is called length of arc. What is this one? Radius vector. These are the various things. Okay. So in definition, what you would say? The angular displacement is the ratio of length of the arc and radius. Okay. So that sounds pretty clear about this one. This is called displacement, but you get an angle of angular displacement. Now the question comes, is this angular displacement a vector quantity or a scalar quantity? It looks like an angle. Whenever there's an angle is there, what does it mean? Is it a vector or a scalar quantity? Now all of us will say, no, it is a scalar quantity. Angle is always a scalar quantity. Remember, there are many things that will go reverse in this particular chapter. Don't think the velocity is same. Last time also just before we saw about the way in which the uniform circular motion, when the velocity is same, don't think the acceleration is zero. Acceleration is there in circular motion. It is always comes in a reverse order here. Now here, though there is an angle which is involved, it is called as angular displacement. This is a vector quantity. This is a vector quantity and it has direction. It has a magnitude and direction. So that also we will clarify here. Okay. Now once we go ahead and do this one, the SI unit of angular displacement is what? Can you just give a SI unit what it will be here? For theta, what we will say? Does theta has a SI unit? SI unit is, look at this one, radian. SI unit is called radian. These all things are very, very important. Please note down this. Unit is radian. What is 1 radian? When 1 radian is going to be equal to, when 1 meter or you can say 1 meter upon 1 meter of radius, then it is going to be called as 1 radian. In other words, this is radius. From here to B, also this delta is going to be equal to 1. That's exactly the same distance of radius. If the delta S and the delta R, which is there, how it could be with the radian? When this delta S is equal to the radius of this circle itself, it goes, then it is going to be equal to 1 radian. Delta theta is going to be 1 radian when delta S upon R, where the delta S is going to be equal to the radius of the circle. When from A to B it travels and it travels exactly the radius of the circle itself, then this is also R, this is also R. What is delta theta? That is 1 radian. Hope you are understanding what it is. Same radius, this also should be radius, distance itself, then the angle swept is going to be 1 radian. So how would you write 1 radian? 1 radian is defined as, please write down, 1 radian is defined as the length of the arc of a circle is equal to the radius. Length of the arc of a circle is equal to the radius. Then the angle subtended, continue, the angle subtended by the arc. What is the angle subtended by the arc? Delta theta is equal to, is said to be 1 radian. Is said to be 1 radian. Now, so what do we write here? Delta theta is equal to r upon r is equal to 1 radian. Please write down this. Delta theta is equal to r upon r is equal to 1 radian. Because it cancels out. 1 radian ho jata hai. Now, you go ahead and draw one more thing. When a particle starts from here and goes totally from one end to another end, goes 360 degrees. From here, it goes, starts whole thing and comes back. How much is the distance it has traveled? From A, it went and came back to the same point A. So its distance is 2 pi r. Right on the next line. When a body travels a full circle, so delta S equal to 2 pi r. So when delta is equal to 2 pi r, what is delta theta? Therefore, delta theta is going to be equal to 2 pi r upon r. Full circle, theta is going to be equal to 360 degrees. So 360 degrees means, what does it mean by that? So when you tell angle as 360 degrees, what do you mean by that? This will get cancelled out. So delta theta is equal to 2 pi radian. 2 pi radian. Please remember. What is 360 degrees in SI unit? In SI unit it is 2 pi radian. Okay. Suppose a particle is here, went on a circle and then came to the next side. It has crossed a full diameter 180 degrees. From A, it has gone to B. How much it traveled? This is the radius of this one. It has traveled how much? Pi r it has traveled. Semicircle. 2 pi r nahi hai. Pi r. So for a semicircle, what is the one? Delta theta is going to be equal to pi r upon r. So what is the radian? Pi radian. So but a body is here, it goes on a thing till this point. This is B. 90 degrees. What is the radian? For a quarter circle. When a body travels for just a quarter circle, theta is equal to how much? Pi r by 2 upon r. This is, what is this one? Pi r by 2. Because it is pi r is whole thing, pi r by 2. Pi r by 2 upon r. So r gets cancelled. It is pi by 2 radians. So we've got three things now. 360 degrees means 2 pi radian. 180 degrees means, what is that one? Pi radian. 90 degree means what? Pi by 2 radian. You can do many things also like this. So many other angles also you can say, but I have just given the basic things about radian. What is radian means? It is an angle which is told in SI unit. SI unit of angle is always radian. Please remember that. Now, here you have a note which is given here. All that I said is here. SI unit of angular displacement is radian. What is 1 radian? Its definition is given here. When theta is equal to 360 degrees, 2 pi radian. And I went on to say about pi radian and pi by 2 radian. It is there. Okay. Lastly, what is the direction of angular displacement? Write down. direction of angular displacement. So when there is a circular motion is there, from here, from A, I'm going to, it is a perspective diagram. Don't think it is a oval. It is a perspective diagram. You'll just saying in an angle and then saying. So it is from A to B, it is traveling from here to here. It is traveled. It is, angle is delta theta. So it is going over like this. When it goes like this, the angular displacement will be along the axis. Please remember, along the axis. You need to just grab it like this. You need to just grab it. If it is a pencil is there, pen is there, and you just hold it together. Now the fingers will point it along the circle. Now you grab it along the fingers goes wrapping around the direction of the motion. So this is the direction of angular displacement. So you can write down what this motion is called. It is, which motion is called? Clockwise and anti-clockwise. This is an anti-clockwise direction. Anti-clockwise direction. Then delta theta is towards upwards. Right. Now go in the other direction here. When the body comes from A towards B, it is happening in the other reverse direction here. A to B. This is the angle. What will happen? Then this is going to be the direction. For clockwise, okay, what is the direction? Delta theta is downwards. This downwards along the axis, upwards along the axis, because it is coming like this. It is going like this. So when you do this way, keep a pen and grab it in the down direction. This is the direction it is there. It is downwards. So you'll see it is coming downwards. Okay. So something like that. So here also you will find when it is going like this, upward direction of delta theta, and it is coming down, it is direction of this one. Okay. So that's the way it is. It is given a thing called right hand screw rule. So you can just see that as a example here. We have explained clearly about just a small definition of delta theta. Quickly wrap up. What is delta theta? Delta theta is going to be equal to delta S upon R. It is the length of the arc upon radius. What is the SI unit? Radians. And what is 1 radian? When length of the arc is equal to the radius. When these two are equal, this also becomes R, this also becomes R, then it is 1 radian. So if it is a full circle, it goes, what is the radian? It is 2 pi radian. When it is semicircle, it is pi radian. When it is going for a quarter of the arc, it is pi by 2 radian. What is the direction of the angular displacement? It is along the axis in the upward direction, and it is going in the anti-clockwise direction. And it is going in the clockwise direction, then it is along the axis in the downward direction. Now with all these things, it is going to replicate for many other examples here. Now we'll go to the angular velocity. Look at this one, angular velocity. The rate of angular displacement undergone by a particle performing uniform circular motion is called angular velocity. Please write down the definition. It is rate of change of angular displacement. What is angular velocity? Angular velocity, it is called as omega. It is called as omega. It is called delta theta upon delta t. It is called as the rate of change of angular displacement with respect to time. That's quite simple. And this is also vector quantity. it follows the same direction of this one. So whatever the direction of the theta, it follows the same. If along this direction, along the anticlockwise direction, the direction of the angular velocity is direction the same, and here also the direction the same. This is the formula for angular velocity. Now, what is going to be the unit? What's going to be the unit of this one, right? So you have to write it as the SI unit of angular velocity omega is equal to radians per second. Please write down radians per second. So that's the way it is. Dimensionally, what is dimension? The dimension is what is that? T minus 1. So that's the way it is told, right? Suppose body goes on a full circle and comes back. In full circle it comes back, then what is the angular velocity? The angular velocity is going to be 2 pi for full circle, for complete circle. So complete circle is theta is going to be equal to 2 pi radians upon t, capital T. So for a complete circle, omega is equal to 2 pi by capital T. It will come so many times. 2 pi by T will come so many times. It always means it is going on a full circle. Now we already know 1 by T is going to be equal to frequency. Frequency is equal to nu. So omega is also written as 2 pi into nu. This is called NEU. Please remember NEU. Nu. What is nu? 1 by T. Frequency. 2 pi nu. It also could be there. Some of them they say 1 by T is equal to N, they say. N is also called as frequency. Frequency. N also can put. But standard is 2 pi nu. Here they have put N. Okay. So the next part is relationship between, please write down, relationship between angular velocity and linear velocity. How do we relate both of them? So first of all, write down angular displacement. So angular displacement delta theta is equal to delta S upon R. Next line is divide both sides by delta T. So delta theta upon delta T equal to delta S upon R is already there, and delta T you can put, right? Delta theta upon delta T, what is that value? We already know it is omega, since delta theta upon delta T is equal to omega. Okay, it's equal to omega. Now delta S upon delta T, what is that? It is called as velocity. So this is velocity. So V by R. Omega is equal to V by R. So what is V is equal to R omega? Please write down this. What is this one? Linear velocity. What is this one? Angular velocity. What is this one? Radius of the circle. So the relationship between linear velocity and angular velocity is V is equal to R omega. R is multiplied with the angular velocity. So omega is equal to V by R, V is equal to R omega. It's written here in the book itself. Okay. So what does it mean by that? The greater the distance of the particle from the center, greater will be the linear velocity. Suppose this R is more. That means it is not a small radius. It is not a small radius, and it is a huge radius. When R increases, what happens? The velocity in which it goes also, velocity increases. Greater the distance from the center, and more will be the velocity. Right? So it's all written there. Greater the distance from the particle from the center, greater will be the linear velocity. Okay. So even the planets also, if you look at the planets, it is revolving around the sun. This is sun. and maybe Venus is here and Jupiter is here. So which one travels faster? Jupiter travels faster or Venus travels faster? Then you can see. But look at this one. When a center is there, same string is being tied. So this one will go small and come back. This one will go so many distance and come back. Now look at this one. The same string where a stone is tied and another small point is also tied here. Same string. So the string goes like this and comes back. Goes like this and comes back. This particle travels only a short distance. This particle travels such a long distance. And what the time taken? The same time taken here also. Same time taken here also. Which velocity is bigger? This velocity will be bigger. This velocity will be smaller. So that's what it's written here. More the radius, more will be the velocity. Which is going on a same, this is static, this is constant. Same angular velocity. Because it is going with the same, this one. Okay. Next one. We'll go to the next definition called centripetal acceleration. What is centripetal acceleration? Right? When a particle performs a uniform circular motion, its direction changes continuously through though its speed remains constant. The speed is remaining constant, we already seen, but the direction of the circular motion constantly changes. Thus, its velocity changes continuously. And that is, there is an acceleration in the circular motion. There is a constantly acceleration is there. We already saw that one. In the direction of the acceleration is always towards the center of the circle. This direction is called a centripetal acceleration. So what do you mean by centripetal acceleration? Whenever a body moves in a circular motion with a uniform speed, that acceleration is called centripetal acceleration. So I would just go ahead to the very first one. Now look at this one. The very first time when we saw this one, I said, so velocity is going this direction, this direction, this direction, and it's having acceleration, acceleration, acceleration. What is this acceleration? This acceleration is centripetal acceleration. It is called centripetal acceleration. It is all directed towards the center of the circle. So in a circular motion, there's only one acceleration called centripetal acceleration. Okay. So the direction of the acceleration is towards the center of the circle. Now we need to derive this particular ones. So derive centripetal acceleration. So you got to first of all state what is centripetal acceleration. The statement is when a particle is moving in a circular motion, the acceleration is toward the center of the circle, and that acceleration is called centripetal acceleration. Now draw this diagram. From P1 to P2 a particle is going. P1, the velocity is V1 in this direction along the tangent. P2, the velocity is in this direction V2, and then this is a radius vector. Write down. Consider a particle moving in a circular path of radius r. Let P1 be the point where the particle starts, and the velocity V1 is directed along the tangent. The particle moves to point P2, and the velocity at that point P2 is V2, which is tangent along with to the direction of the circle. This entire thing you need to write. Whatever I have said the previous lines, everything it should be written like that's what it's written here. Okay. So write down the change in velocity. The change in velocity is V2 minus V1 is equal to delta V. V2 vector and V1 vector is delta V. Alright. So that is the value here. The next one is we need to find out the angular displacement. The angular displacement. What is angular displacement here? So delta theta is going to be equal to, what is angular displacement? What is the length of the arc? Write down the length of the arc. It is P1 to P2. P1 P2 divided by, what is the angular displacement formula? The length of the arc upon radius, it is radius. This is equation number 1. This is according to this particular thing. Now what we do is, what we are doing here is, the circular motion is here. Alright, this is the circular motion here. and here this is the angle, this is the velocity v1 and this is the velocity v2. So here you get here and here you get this one. So the tangents are here. This is delta theta. Now project this one much higher. Project this one also much higher. I hope you would have learnt about the quadrilateral. This is theta means what is this one? Exterior angle of a quadrilateral. This is like this. This is going to be delta theta itself. Now this is v1 vector and this is v2 vector. What is this one? Delta v. So look at this one. Look at this diagram. That's what they have drawn here separately. I just made it here itself. They have removed this triangle and they have drawn it separately. v1 vector is A and v2 vector is here, and then that is delta v. So what is the angular displacement keeping this triangle? Delta theta is equal to delta v upon v1. Fine, I am again explaining here. There are two triangles here. One is p1 p2 upon radius, length of the arc upon radius. The next one is the projection is the velocity vector here, and the velocity vector v2. These two velocity vector we are saying v1 and this is v2, and then there is definitely an angle of exterior angle is there, that's also delta theta. So what is that angular velocity, angular displacement here? For this kind of situation of v1 and v2, it is going to be delta v upon v. So p1 p2 upon r is equal to delta v upon v, equating both. Delta theta, you are equating both. Okay, now once you have equated both of them, so what is the next one you're going to get is, this is delta s upon r, alright, and this is delta v upon v. We already know this one. Delta s upon r and delta v upon v will be the value. So what is delta v upon v? Delta v is equal to v into delta s upon r. Okay, so this is the next part of it you will get here. Right, now divide on both sides by delta t. So here also delta t, here also delta t. So you can put delta v upon delta t is equal to v into delta s upon delta t into r. So what is this one is called? Acceleration is equal to v into, what is this one is called? Again velocity. V is equal to delta s upon t, also the v upon r. It is all looking together. Acceleration is equal to v square upon r. That is called centripetal acceleration. This is called acceleration. Centripetal acceleration. Very, very important derivation. This derivation always comes every time. Please remember this one. So what we did, there is two angular displacement, equated both of them, and we took delta v separately for some reasons, because we wanted to find out the acceleration. So delta v is equal to v into delta s upon r, divide on both sides by delta t. After we do this one, this entire part is called acceleration. This is v, delta s upon delta t is again another v, and you get divided by r, v square upon r. We already know omega. What is omega? So omega is v is equal to we already saw r omega. Since v is equal to r omega, so put this one. So it is also called as acceleration is going to be equal to r omega the whole square upon r. So what is acceleration is going to be equal to? It is going to be equal to r square r omega square. It is also another formula of this one. R and R will get cancelled, one more R will be remaining, r omega square. So centripetal acceleration is also called as A times of r omega square. Now look at this formula. The formula is A is equal to v square upon r, A is equal to r omega square. Now look at this one. We know always acceleration as v by t, delta v by delta t. But here acceleration is v square by r, because the radius is important. The body is going along the circle. Again, r omega square. What is omega? Angular velocity. What is a? Angular acceleration. So it is called the centripetal acceleration. Okay, so that is called the a part of it. The last part of it, I'm just finishing this one. So it is called as angular acceleration. So angular acceleration is nothing but delta v by delta t. Okay, so it is called as the tangential acceleration, delta v by delta t. So that is also called as, in other words, it is called as the radial acceleration is called as v square by r. So there are two things. When a body is going in a circular motion, there is a tangential acceleration, there is an angular acceleration. So both of them, if you tie up together, it will be, now look at this. Look at this one. Tangential acceleration is this one. This is the usual acceleration, delta v by delta t. Delta v by delta t. And then what is this direction? Along the radius, it is the centripetal acceleration. So put together ar square plus at square, and you need to finally have this as an equation. Alright children, I'm just done with this one. You can read the definition of centripetal force yourself. You know centripetal force many times. Just read it yourself. So it is just up this one of here, centripetal force. What is force going to be equal to? Mass into acceleration. What is mass? Same here. What is acceleration? This is the centripetal acceleration, v square by r. Just now we saw v square by r. In other words, acceleration already called as r omega square. Just put this one. So this is called centripetal force formula. And you can read this one yourself. I'm just closing here. With this, it gets to an first part. Lesson is over. We'll go to the next one in the next class. Thank you.